Hello, everyone, and welcome to this session. I'm Amin. I'm in charge of marketing for P1 Security, and with me is Mehdi Regragui, our head of security consulting. How are you doing, Mehdi?
Hello, Amin. Hello, everyone. I am fine, thank you. What about you?
I'm doing great. Thank you. Very excited for this session. I see that we have a lot of people already joining us, so feel free to say hi and let us know where you're from. It's always good to have people from all over the world. And we will be waiting a couple of minutes, of course, for people to join before we start the session.
Okay, so I see already some greetings. Hi, Clayton. Hi, Martin. Hi, team.
We really do have representation from a lot of countries. She's always great to see.
Indeed. Yeah.
So, Mehdi, while we wait for the session to start, a couple more minutes, can you give us a quick word about this webinar?
Sure. So maybe I can start already sharing my screen. So preparing slowly. Okay, tack. Everything is okay? Do you see my screen, Amin?
Now, yes, we do have it.
Great. Oh, I think I'm not into the... Oh, no, we are good. So today's topic will be about the IMF. So IMF as a network function within the 5G core. So when I look today about the solution and implementation of network function, specifically into the 5G, we are not anymore into standalone network function that will do hosted alone and will do some specific operation. Today's solution with the 5G, they are more into the cloud native and also this microservices approach and implementation. And we end up by having one solution or IMF within a whole ecosystem or infrastructure. So when you look at it in details, you have a lot of, I would say, technologies involved from infrastructure perspective, protocol perspective toward the application perspective, where we're going to have a mix of IT and also telco protocol. So for example, for the 5G core, we know that we have the HTTP2 protocol with data serialized with the JSON. So HTTP2 protocol is a web technology now that we put and we embed within our 5G core. And into the same time, IMF will have, of course, the NAS NGAP messages. Also, we'll do some GTPC, and we're going to see this later. So this is some kind of telco also protocol. And then when you look at the infrastructure perspective, you have a set of Kubernetes virtualization, containerization that is happening. And you see that the attack surface now, it is really increasing. We are not talking about it as an isolated, how can we compromise the network function from the service that is proposing? No, now we can compromise the IMF from different angles. So again, coming from protocol level, infrastructure level, top until the application level. And when we try to do a penetration testing or security audit onto the IMF, now we will need or require a lot of skill sets that are both coming from the IT perspective and the telco perspective. So this is why at P1 or within the team, we have different skill sets, some experts into specific protocol domain or multiple protocol, and others into the other part of it. So to summarize, this presentation will be more a compilation of the attack surface vulnerabilities that we identify, and all this compilation, of course, is coming from the different research and work that is done within the team.
Thank you, Mehdi, for this quick presentation and introduction. So I think we're already after 4 minutes. Just two quick notes from my side before I hand it to you, Mehdi. This session will be recorded and will be sent at the end to everyone who is registered and present. And for the Q&A this session, we'll give between 10 to 15 minutes at the end for all the questions that you have. So feel free to shoot any questions that you have in the chat or in the Q&A session part, and we will tackle them at the end. So Mehdi, it's over to you.
Perfect. So let's talk directly and move to the agenda. So I will be talking about the purpose of the AMF network function within the 5G core. Then we can see some architecture interfacing toward the AMF, and we start really giving some example of AMF implementation and solutions that are coming from vendors. So for this one, we have two examples that will be coming from Ericsson as well as Nokia, and also some public vulnerabilities that we know today about the AMF. So we finish by a recommendation for security improvement and of course a Q&A. So please do not hesitate if you have a question, you put it in the chat, and at the end I will try to tackle them. So now regarding the AMF, so AMF for the 5G core, it's the preceding the MME for the 4G network. And the AMF will be handling all the mobility and management functions within the 5G network. So the user equipment, they will need to access, of course, the network. The networks will be, of course, needing to access the user equipment, and also the UE will need to be able to communicate with other UEs, phone calls, and so on, and also via the internet. So this is not possible without the first mobility and management procedures, and this is the one that they are really handled by the IMF. So it will allow us to perform all this mobility and procedure management, seamless and continuity of the service and connectivity of the user equipment. It could be also other type of setup. It could be IoT that they are moving, or any type of assets, and also handling the security management, the security procedure that need to be established between the UE and the core network, so we can exchange some signaling messages in a secure way in terms of confidentiality and as well as integrity. Without talking about the role of the IMF within the 5G core as an entry point toward the core network, and it will be as a gate to forward some messages toward the other network function and collaborate, if I would say, with them, so we can establish and handle all the procedure and therefore the attachment of the user. So this is why this network function, it is highly sensitive, not only of the services that it holds. So as we said, it allows the attachment, or it contributes, and this is the entry point for the attachment of user equipment. It allows to establish the security. It allows to do the seamless connectivity and continuity of service for user equipment, but it also holds a lot of interesting data related to the user equipment context. And this data that it holds could be used either for espionage. So for example, we're going to have the location, the recent location of the user equipment. We're going to have all the association between the GUCI, TMZ, and the MZ or the SUCI. So all the temporary identifiers that have been created for a specific user equipment, so we can hide this identity and therefore limit the tracking. So if it is got attacked as a denial of service, so we have a discontinuity of service, and this is something that the operator cannot afford. If we got compromise it, but therefore we don't want to perform denial of service or disruption of services, so the attacker, they will be able to perform signaling intelligence. Know what are the persons, for example, they are connecting right now within the network, and also if they have access to the user data from different manner that could be possible, either by being into the middle or by compromising other network function, we can be able to do the relation between this user data traffic. It is related to specific user. Now let's look at it from the network representation related to the release 17, and we see that the IMF as the entry point toward the core network. So allow me to put a pointer. Is there a pointer here? IMF is an entry point toward the core network, where it will be in communication, of course, between the RAN, so which will be like gNBs, where the UE will use the gNBs to be able to communicate directly with the AMF. And also related to non-3GPP RAN, so they are using some other access network points, so for example, using the Wi-Fi as an example, and then via another network function into the IWF, they can communicate to the IMF and also exchange some NAS messages. So the reality from architecture perspective, we see that the UE perspective could communicate with the IMF and the UPF for the user plane. So once again, IMF for signaling, user control plane, and UPF will be from the data plane. But when we analyze it deeply, it may be not necessarily true. And this is like a big parenthesis in a way that the user equipment is able to communicate also with the SMF. Via the same relation, the UE communicate with the IMF via the gNB by forwarding the messages within the NGAP message. You know, the NGAP message, we're going to put the NAS payload and we send it to the IMF. So the UE via the NAS messages, especially when we have the attachment that have been done and the UE, they want to open a PDU session, they will send some payload within the NAS messages that the IMF, when receiving it, it will just take it as it is, put it in an HTTP2 request and send it to the SMF. And this is, it may be another topic in a way that we can reach, we can provoke, we can compromise the SMF from the UE perspective. The only difference from the analogy that I gave is that the NAS message, it is signed, encrypted from the UE perspective and to the IMF. The difference from the UE perspective and the SMF is that this decryption of the NAS message will be happening to the IMF, and then the IMF will take it and put it, construct these HTTP2 messages and forward it without prior validation and let's say prior validation to the SMF. So which means that the SMF is the one to have this gate or control toward the message sent by the UE. For the others, for example, when we want to do an attachment, so a lot of information element included within the NAS message, so it could be, for example, the IMSI, element IDs, and so on that are coming from the NAS payload, they will go to the AMF, and therefore the AMF will validate them before requesting other network function. It could be IUSF, UDM for authentication, and so on. So from the interfacing and the different interconnection between the IMF and the different component, so either outside, it's either within the 5G core network or outside the 5G core network, so we can see multiple or multitude of interfaces. This schema here, it is not listing all the interfaces that where the IMF it is involved or serving. But we can see that from the UE perspective to the IMF, we are using the N1 interface. So the N1 interface will has the NAS protocol, non-access stadium, and this will be forwarded from the gNB toward the IMF. Then we have the intro interface. It is an NGAP interface based on the SCTP protocol. Then within the 5G core network, we're going to have a multitude of other network functions. So the most important one will be the N11 between the AMF and the SMF, between the AMF and the UDM, and also the IUSF. So all related, for example, to the authentication. And of course, the IMF communicate with the NRF if it is existing within the 5G core, so we can select the different network function that the IMF would want to communicate with what to communicate to. So by checking all these interfaces, we can consider that each interface could potentially constitute an attack surface from UE perspective, from gNB perspective, and also from within the core network. But the attack surface is a little bit more larger than that because it's not fully represented by this diagram. So now let's have a look about the different attack surface and risk related to this network function. So we're going to have all the UE part from UE per malicious UE, SDR, for example, software-defined radio, or all malicious CPE or non-3GPP, for example, network, right? Then risk will come from the gNB itself. Even though that the gNB, it is an asset within the authority of the MNO, it constitutes a risk because attacker, they can breach cell sites, for example, radio cell sites. Radio cell sites, they are spread on the whole country where an MNO will have like thousands and thousands of them, and sometimes they are not physically secured. So it means that the attacker, they could breach this facility, and while breaching this facility, either they're going to plug to the field network, and therefore we're going to have problem of network segmentation, for example, and we can access from the gNB network over the field network toward the AMF, or even in case, let's say, if we have security in place like IPsec between the RAN and the core, so the attacker may be able to compromise the gNB from the physical access, and therefore will benefit or will leverage the setup IPsec connection between the gNB, the RAN, and the core, and therefore attack the IMF, or multiple ones, of course, because the gNB will be connected to multiple IMF, or also in case of RAN sharing or MOCN, we can even attack multiple MNOs by gaining access to only one radio cell site facility. Then we have the compromised network function. It means that the attack, it is coming directly from the 5G core network. Well, we can say that this is less likely to happen because the 5G core network, it is not exposed to internet. That is true. The 5G core network, it is in a separated OT, let's say, network, and it is not, for example, directly connected to the IT network. So we have some kind of segregation. Only specific contributor or employee, they're going to have access to this network. The reality today is compromised NF could be coming from supply chain compromise, and we can compromise a vendor. And by compromising a vendor, it means that we can ship some malicious code within the network function and the solution, and therefore we're going to end up by having some rogue NFs or malicious NFs within the network. And this kind of scenario, it is a high risk, and it is possible to happen because when you look around and you see how much vendors that they are serving or providing network functions, they are not that many. You can count them. So from a threat perspective or a threat actor that could be, for example, nation states or something like this, compromising a vendor as a supply chain risks have a lot of benefits because compromising one of the biggest one will lead directly to the compromise of multiple operator within different countries. Then we have the attacks that will be coming from the interconnect IPX roaming perspective. So today we can say that it is an imminent risk. It is not this is the case today because we do not see much the 5G roaming deployment yet. But when that's happening into the future, so the attack could either be coming from malicious or compromised MNO, and therefore the attack could go toward the IMF via the N32 interface via the different SEPP. Then we have the operation and management. So the operation and management here we can consider two types: either direct operation and management, and those are services of operation and management. They are within the solution itself. It could be CLIs, it could be netconf, it could be web applications, or third-party 2PP network management systems. So either we are using the same vendor for the network NMS solution or the OSS solution, or we are using another vendor or in-house build of the NMS and the OSS. And therefore, the attackers sometimes they don't even need to go and compromise the 5G core network. They just need, from the IT perspective, problem of network segmentation, or they compromise the right administrator. They have access to the NMS system. NMS system have been compromised, and therefore they will be able to tamper with any network function within the 5G core. So I saw already gNB risk with IMSI catcher 2. That is true. That is true. Normally, this IMSI catcher, it should be disappearing with the 5G by the implementation of the SUCI. But we know that it is not the reality today. Either the SUCI that is supposed, for example, to encrypt the IMSI, either it is not implemented or it is implemented with a null scheme. So it means that the SUPI, it is sent like this, or sometimes the SUCI will be as a permanent identifier, for example, with some kind of misimplementation. So it means it's true we have a SUCI, but if this SUCI it is not modified every attachment, so it means that it will constitute a new identity of this user equipment. And when we talk about the IMSI catcher, we can also talk about this other variety that will do, of course, the downgrade attack, as long as we have, for example, the 2G that is supported not only by MNOs, but only by phone. It is still a risk of man in the middle and therefore spying on users. So now the IMF attack surface. So if we look, this is just another view. So we see that we have the attack coming from the user equipment, from the gNB using the NGAP protocol, from the SBI, from the roaming perspective, and also, this is, we will not see it into the previous diagram, from the N26 interface. So this is an optional interface if we want to interconnect or do a fallback from the 5G to the 4G. So it will connect the AMF with the MME using the GTP C protocol. So, and again, we are looking for vulnerabilities and bugs within the implementation of the solution, IMF itself. We are attacking IMF also because of the subscriber data that it holds, more specifically the UE, the IMF UE context that will contain the IMF keys used to encrypt, for example, and do the integrity of the NAS. We can know the SUCI, the SUPI, the TIMSI, and all their equivalent. We can know the IP address and also what are the PDU session related to this specific user. And also, if we have an IMF as a network function that is compromised, we can start communicating either as producer of data, so an SBI producer, or it will be as a consumer of data because it has access to a lot of other network function, and therefore we can try to grab or gather sensitive data. Now, let's look about the UE attack, really, and the gNB attack. One of the questions I have already got asked by MNOs was, what is the real status of the deployment of the IMS in terms of robustness? Are today the IMF really robust from an attack perspective that is coming from the UE? So the reality, or to answer, is that it depends. So mainly it depends on how much effort the vendor it is putting to secure the IMF in terms of stress, fuzzing capabilities. And second, sometimes we can avoid some vulnerabilities just by going back to the basics. And going back to the basics is performing proper hardening of the OS level, infrastructure level, and the application level. So at P1 Security, we have found multiple vulnerabilities toward the AMF from user perspective. They are going from denial of service and also direct compromise. Direct compromise meaning one malicious NAS message will be processed by the IMF, provoking a denial of service, and therefore we can have an execution of command from the UE perspective. So this is the maximum risks that we can have or we can achieve, because the requirement for that to happen is that user equipment having one SIM card and therefore attacking the IMF. And when we look at it, sometimes it's like the binaries that they are handling, the signaling part, as I said, they will be compiled without security hardening. For example, the buffer overflow that will be provoked, when we look at it at the address level, we don't have, for example, ISLR protection, canary protection, and so on. So it means that all these capabilities or security capabilities that could have been built within the IMF to give it a better security and somehow help mitigate the vulnerability, they are not existing. And all of these, they are increasing the risk of the compromise, especially into the AI era that is now helping the attacker to find a lot of vulnerabilities quickly, do augment some threat actor, for example, that they don't have the capability now. They could, if they manage to access to solution from the vendor, grab the different binaries and therefore run AI on them and try to find these vulnerabilities that they could be weaponized by threat actors. And from the gNB perspective, we already have demonstrated multiple times denial of service attack via malicious rogue messages via the NGAP stack. Same occasion. Here we have the SMF here because we have already shown that it is possible from the UE perspective. We can achieve a remote code execution toward the SMF following some mobility session management procedure that they will be, of course, contained within the NAS messages. And the IMF, as I said earlier, it will just decode the NAS messages, decrypt it if there's encryption, and check that it is really coming from the UE, from the integrity protection, build the HTTP2 message, and embed these messages toward the SMF. And of course, the SMF, it is not well protected, and therefore it's gonna provoke some vulnerabilities. So when the attacker managed to access now the facility, the physical facility, and therefore, let's say they are able to communicate with the AMF. So not only they will try to, let's say, send some malicious messages that will cause disruption. So if we cause disruption within the AMF, this is bad because new user, they will not be able to do attachment. Known user, for example, that they are traveling or moving, they will not be able, for example, to establish the continuity of service. UEs that they will need to update their location via some management procedure, they will not be able to do so. So it will not only affect new subscriber, but also some existing subscriber within the network. But there is something also much more interesting. It is a possibility of man-in-the-middle attack, because when we manage to, let's say with SDR, we are able from the gNB perspective network to communicate within the IMF. We can trigger the procedures that will allow us to register, for example, a gNB. And if we spoof a gNB IDs and relevant parameter, we are able to eject legitimate gNB from the network, and therefore having the rogue gNBs that they are operating. And if we have rogue gNB that they are operating, they will be the one relying all the NAS messages toward the corresponding IMF, and therefore managing the man-in-the-middle attacks. Then we have the core network attacks. So this is either coming from the intra-P element, or the inter-networking between the 4G and the 5G, or between inter-P element ID in case of the roaming. So let's put the roaming aside, since we don't see it, let's say, yet a lot. And from the internal perspective, or the communication from the between the different network functions, now we have a new protocol that is based on into the HTTP2 and serialization with the JSON. The reality, it's like sometimes we still see the support of the HTTP1 protocol. Even though we can look at it in terms of, yeah, but this is just another version, the reality is that HTTP1 protocol, especially when we have a lot of hops that the information need to take to travel and get to the right assets, so for instance, the IMF, we can have a lot of type of desync attacks. And this type of attacks, they have been mitigated or removed by the adoption of the HTTP protocol. So we're going to have all the stack of the HTTP2. HTTP2 into the 5G core network, it is something, let's say, new, and we still see a lot of problem of parsing of the JSON data. Sometimes this JSON parsing, it could be just classic bugs. Sending malformed JSON will end up by causing a denial of service within the network function. And also here we can already talk about the implementation of TLS, MTLS, ultimately OAuth2. So this is something that we do not see today. And maybe if I need to give it a percentage, because this is something I also have been asked, we can see that we have a 50-50. Some operators that really have the TLS stack with MTLS deployed, and others, they have non-encrypted SBI within the 5G core network. And finally, this interco between the MME and the IMF, here we have the gTPC protocol. And of course, if it is optional, if it is implemented, it could constitute an attack surface for denial of service, for example, for an attacker that is already within the network. Then we look about the operation and management domain. So operation and management, from threat perspective and compromise, this is the favorite attack path for the attacker, and for several reasons. Operation and management has the ability to configure a network function. This is one. So they have a lot of sensitive operations that can be done. Second, it has a lot of IT perspective protocol. So we can talk about SSH, netconf, SNMP. We can have web application and so on. So it means that this is the attacker they master. And also we can have a lot of hardening problems, default password, problem of network segmentation, and so on. And if we compromise the operation and the management, we are taking the full control of the network function. It may happen that there are some network segmentation problem in a way from the run facilities, cell site, we can reach some operation and management from the AMF perspective, as it is the entry point for the 5G core. So this is could be possible, and therefore the attacker, they can use it so they can do a pivot and have a foothold within the solution. And when we talk about the operation and management, as I said before, like, we can also have this third-party 2PP solution that they are the big NMS solution, network management system, that they could be compromised, and therefore they could give access to the network function. And we have also the infrastructure level. So today, network function, they are built on top of Kubernetes. Sometimes we have the OpenShift. So we have some we have some vulnerabilities related to the infrastructure itself. For example, OpenShift, they will have some specific service of ignition within the OpenShift that they are by design non-authenticated. And the only mitigation that is possible is to do a proper network segmentation and have only specific set of IPs, notably the cluster, that they need to access to these interfaces. Sometimes it is not the case, and therefore it is a way to compromise. This is the thing. There are ways to compromise the network function without even touching on the services that are provided by the network function. We are going from pure infrastructure level. We compromise the infrastructure, and we're going to compromise, therefore, the AMF solution and all the other function deployed within the same cluster. Now let's again focus into the IMF threat landscape. So from the IMF perspective, the attacker will look for denial of service, will look for compromise, will look for the data leakage. So all in all, either we want to disrupt the service, or we would like to perform signal intelligence, because we're going to have a lot of highly sensitive data, allow tracking of user, location of user, and so on, and also map the GTP, also map the data plane to the signaling of the user, and we know that this data belongs to this specific user. So in terms of denial of service, in reality, a lot of them, they depend on the specific implementation that is coming from the vendor. But into the specific implementation, we can already distinguish two types, either protocol-based DOS, and with this one, I refer to the all scenarios that they are known that could lead to disruption, denial of service of the AMF, and therefore they are well documented within the SCAS documentation of the 3GPP. Then we will have proper implementation of the vendor, where we can have JSON parsing, some specific malformed NAS messages, NGAP messages that could lead to this denial of service, and finally, flood attack, sending multiple messages and see if rate limiting, firewalling, and so on, it is well implemented. So we can stop this type of threat. In terms of compromise, so either we're going to attack the AMF implementation and look for vulnerabilities related to buffer overflow, operation and management vulnerabilities, it could be SSH, netconf, web application, and so on. Supply chain threat that could come from open source libraries that we are using, or directly from the vendor, or through the NMS system that they are configuring this network function. Data leakage could be related also to the design and implementation. As an example, we can find some improper logging of user data within the logs, and this data could travel several systems, and therefore it exposes the sensitive data of users into several systems. I will try to give one example per category that I have discussed about. So these ones, they constitute as an example of the scenarios that we can have into the AMF implementation. So protocol-based denial of service, so this is a scenario coming directly from the GPP SCAS document, where UE will, either after a normal registration procedure, so we are registered to the network, we're going to try to send synchronization failure. Synchronization failure toward the IMF and the SIF. Already here the IMF need to be able or have proper implementation to see that this user, it is already authenticated, he cannot send me authentication failure related to synchronization. And therefore, this should be stopped. Lack of this implementation, meaning that the AMF with the inner SIF that is implemented will forward downstream these messages to recalculate the RAND express values for the authentication of user. So it means that multiple messages like this will not only potentially lead to the IMF resource exhaustion, but also it will impact the UDM and the UDR with the backend, because they will be doing a lot of cryptographic work in order to extract the cryptographic materials related to the authentication. So usually, AMF solution and a lot of known vendor, they are already certified by NISAS. They are already tackling these kind of scenarios, and therefore a NISAS certified IMF solution will be mitigated against this type of risks. Now let's have a look about the compromise threat, and this is coming directly from the implementation of the vendor. So it could be either buffer overflow within the application, and also coming from NAS messages, HTTP2 messages, and so on. So here is an example that I like to give. This is some kind of scenario that we have demonstrated against an SBI interface against a network function. And this kind of scenario showcase the adoption of HTTP2 protocol within the 5G core allows the inheriting of vulnerabilities of the web technology. For example, server-side request forgery attack. Maybe they were not something before into the previous technology, but now with the adoption of the web technology, they are becoming relevant, and therefore they could lead to the compromise of a network function. So quickly, here is an example. So all the network functions, they are not directly exposed into the SPI interface. They have some reverse proxy on front of them, and this reverse proxy, they will forward the upcoming SPI request, and therefore send it back to the backend that is handling this data. The thing is, like, reverse proxies, they could be vulnerable to server-side request forgery in a way that the attacker, what does that mean? Attacker, they can send a message to this reverse proxy and leverage the reverse proxy to forward this message not to the SBI interface, but rather to another internal service within the network function. So, and we end up by sending HTTP request, embedding some malicious header that will, from the SBI interface, will be forwarded to an internal service of the network function that is handling a command line interface. We were controlling via HTTP execution within the command line interface, saying, can you please retrieve one malicious library from the attacker machine. Redoing the same scenario and same attack, can you now load this malicious library? And by loading this malicious library, we can achieve a remote code execution and have an access to the network function. And finally, I see that I have lost my camera somehow. So now it's come back. Finally is the data leakage. So this will be related to improper logging and auditing. So it happens that the AMF, it is locking some sensitive information. Sensitive information could be related to the UE context. And if it is locked and within the system, so either it is via some other services, it could be some log shipping services that are handling or taking these logs from the AMF, and therefore these log messages could travel other network functions, other systems, syslogs, and so on, and therefore they could lead or increase the compromise of this data. And this compromise of this data, it could be the IMSI, it could be the IP of this user for this session, the equivalent SUCI, SUPI, 5G, TMZ, or GOTI, and so on. Now let's have a look about example of solution that we have into the market, and they are implementing the AMF. And we're going to start by the Ericsson PCC. And here we are going really into another dimension that is changing a little bit our perspective. The AMF is not only one standalone network function that is doing some kind of operation, it is part of a whole ecosystem or a whole infrastructure within the solution. And therefore, some of the solution, for example, Ericsson PCC, it implements the dual core. So we can have into the same deployment, MME, EGW, PGW control plane, AMF, SMF. And here we have a complexity exploder. So it means that one solution now have a lot of interconnect between different signaling core networks coming from the 4G and the 5G, a lot of operation and management, and also legal interception because of the SMF, and the infrastructure, of course, the infrastructure level, UE and the RAN. So it means that you don't need today to go directly to the IMF to compromise the IMF. It is possible that if you are able to find a zero-day or a vulnerability within the MME implementation of the PCC, if you are using the dual core mode, from there, the compromisation, from this compromise, we can attack directly the infrastructure. By infrastructure, it means trying to perform privilege escalation within the workload, within the Kubernetes layer. And if this is successful, we are not only compromising the IMF, the MME, we are performing at the same time lateral movement and compromising all the resources that they are linked to this deployment. Similarly, for Nokia, we have the Nokia CMM that is providing the implementation of the 2G, 3G, 4G, and 5G technologies, all the mobility and management functions from the AMF, MME, and GSN. So same again, we have an explosion of complexity. And when we have an explosion of complexity, is directly equal or have an impact on security. Because like now that we have everything into one cluster, how do we handle the network segmentation just within the same cluster? We have one workload, either from the operation and management or the signaling have been compromised, either direct compromise or via, for example, the supply chain. How can we master that this network function or this workload is not able to communicate with other workloads within the cluster? In my opinion or my experience from the deployment that I have seen, a lot of MNOs, they are failing on it. Sometimes MNOs, they are handling this part in a way they are taking the solution from the vendor and they are handling the infrastructure via, for example, Red Hat and so on, with the management coming from the Red Hat and so on, and the vendor, they are giving only the solution. But I want to be extremely clear here. It's like, I'm not saying or pointing that this kind of architecture, it is insecure. I'm not saying this or this is something bad. What I am saying here or try to point out is when we have complexity, security become hard. And therefore, there are many places where it can go wrong and lead to bad security. And bad security in one workload will impact everything. So we can say that the solution or security perspective, or the security robustness of a solution from a vendor depend or is the same security level of the weakest point. Because if this one compromise, we can have the control of the whole solution. And now let's talk about some vulnerabilities, public vulnerabilities related to the deployment of the AMF. I took, for example, here the example of Ericsson because they have shared some vulnerabilities related to this, and we can use them as a use case to see where we do things wrong. Already that we have vulnerabilities coming from the IMF and the vendor, I believe this is a great progress into the industry in a way that we want to be more transparent. This is really great to see, so we can know what is happening, but we still lag, we still lag behind the industry in terms of security, as either the vendor, they will take a lot of time, 1 year, 2 years to fix the vulnerabilities, or sometimes they fix some vulnerabilities, and therefore these vulnerabilities, they are silently fixed, and no one is aware of them. Some of these views, they say like, there is no need to put CVEs, because if I put a CVE, if I inform all my clients and I patch their system, it is okay. So there is no need to have the CVE. But when you look at it, it is really good to have this kind of transparency. And let me give you an example. If we look at the CISA non-exploited vulnerability, so it will be a catalog with different CVEs, and it will tell us this CVE have been exploited into the wild. Today, from our threat intelligence perspective, we do not know which kind of vulnerabilities or threat actors are using against the telco equipment. Have they already used the CVE that is known against the AMF or against the network function? If we do not have a numbering, it cannot appear into, for example, the CISA catalog, and therefore we can be blind and we cannot know what are the real places where the effort should be set, and all the industry could learn from it. So what you see here highlighted in orange, they are vulnerabilities that found by P1 Security and reported to the vendor via our MNO partners. So I will take 2 examples of those as a case study to see where things can go wrong. So the first one is a remote code execution. So this is the last one that is came out into the PCC, remote code execution on the mobility management controller. So remote code execution, it means that the attacker is able to send a payload, and with this payload, it is able to execute remote code execution and therefore take the control of the network function. This vulnerability is coming from the operation and management domain. So as a prerequisite, the attacker needs to be within the network. So we consider that an attacker coming from the internet, compromise the external asset, and now is traveling within the core network with the intent to compromise the core network. So since that everything now we have within the cloud native, we have a lot of workloads within the cluster, and each workload have specific function, and this specific function is part of the microservices architecture. So even the CLIs, the command line interface that will allow us to send a command to configure, for example, our AMF, will be segregated in a way that we submit a request toward the command line interface. The execution or the configuration will not happen within this specific workload. It will happen into another workload. So we're going to have an internal communication between a management command line interface and the pod or the workload that is handling or issuing after the configuration toward the specific pod that will do the signaling. And what we see here, specifically for this vulnerability, the execution is happening as a root. And really, when you zoom at it, and we go to the vendor and we say, or the operator, we have done an audit of your infrastructure, and we have seen that some workload that they are privileged. They could run as root. Why this is a problem? Because if they are compromised, it will increase the possibility of host escape. What host escape, it means I will go from the pod level to the host level, and if I am into the host level, I compromise the whole solution. This is the same example that I was given from the MME toward the IMF, SMF, and so on. But the reality, if you go with this kind of scenarios, and you don't have a proof of exploitation, they will say like, but this is a local workload. This workload is not exposed into any of our external interfaces. So we are accepting the risk. It is okay until a moment that we have a way to bypass this isolation from internal perspective to external perspective, leveraging the external interface. So this is similar to the server-side request forgery into the web application. And this server-side request forgery, they are not anymore web application vulnerabilities. They become just application vulnerabilities because we can have server-side request forgery from the CLI perspective. Then the second one is a medium one, and this is it was the last one within the list, and this is improper input validation that could lead to disruption of the service of the AMF from the perspective of a malicious gNB. And this attack have also being demonstrated is one of our red team activities. In a way, we went on site, security breaches have been done. We are inside. We managed to connect to the network, compromise the gNB, and therefore from there we are able to communicate with the AMF and submit the malicious, malformed NGAP messages, and therefore cause the disruption of the service. So on the whole, when you look about the different vulnerabilities coming from the IMF, so as I would say, the conclusion for this kind of vulnerability. So it will stem from implementation perspective, so related to the infrastructure, and sometimes you are just want to say, do the hardening guideline. Just do homework, because if you do well the homework and the hardening guidelines, this will save you or protect you from a lot of vulnerabilities as a mitigation perspective. But sometimes the vendor, they will say like, this is internal. I will give it access to the host without problem because there is no way to reach it until it is proven. Sometimes it is related to other function of the IMF. It will be generation of TMZs that will allow to protect the identity of the user, and therefore it will be either sequential or the entropy, it is not enough, and therefore we can know, or we can know this MZ or this TMZ belonging to each user within the network. Sometimes we can establish the NAS confidentiality to NAS scheme, and therefore we can force it, and the NAS messages will travel in clear text, and the IMF, it is not taking this into consideration by rejecting this kind of messages. Now, as a conclusion for the vulnerabilities, and I want here to emphasize where the operator, they should put the effort, especially into an era where we have the AI. It is able to discover a lot of vulnerabilities. And because it is able to discover a lot of vulnerabilities, that may seem that it's a good thing, but into the other hand, it could be a bad thing. It means that we have a lot of vulnerabilities, we need someone to fix them. So the AI usage is increased, but I am not aware that in the defensive side, within the team of the vendor, the team have been increased in a way to tackle all the flow of vulnerability that is coming. So it means that the industry needs to focus into the right security measure. And the right security measure, they are not saving from a zero-day attack. It is no, from going back to the basics, know what I have within the network, and put robust network segmentation, put robust hardening guideline from infrastructure level, from user perspective level and authentication, from binary level and implementation of this ISLR, canary, and all the binary protection, and so on. So this is the reality that will help to increase the security of the operator, and therefore the underlying network function. Of course, enhancing the login and monitoring. We need to be able to monitor what is happening. So we are able to do a proper incident response when we have an intrusion, and conduct regular security testing. Today, there are a lot of solutions, either based on the AI, etc. It is possible also to use some AI and being sovereign by using some open models. So all these opportunities today, either some external penetration testing or starting leveraging AI, could help the detection, of course, and the remediation of these vulnerabilities. For further reading, we have maintaining security built-in page with CVEs that stem either from the vendor perspective or also from open source perspective. We have in many time or many occasions discovered some crash related to open source implementation of the 5G core, so related, for example, to the AMF, SMF, and so on. And also we have an article talking about the fuzzing capabilities and how you can conduct successful fuzzing and discover vulnerabilities within the telco protocols. And with that, I finish my presentation and will lend it to Amin.
Thank you, Mehdi, for this amazing presentation. We already have a few questions in the Q&A section, so you can check them out. But from my side, before we wrap up, I just wanted to share with you something that we have been working on for the past months. We built a 5G core check. It's a free self-assessment platform that helps operators and telecom professionals quickly evaluate security posture of their 5G core. So in just a few minutes, you receive a personalized score along with practical recommendations. And of course, at the end, there will be a report to check. So this is a first look. We haven't shared it yet. We will drop the link in the chat, so feel free to play with it, check it out, and send us your feedback or any questions that you have. So we can, I think, move on to the Q&A. There are already some questions.
Yes, so I see one question from Madhu. What do you think is complementary source of TI? I think test. Don't know what does that mean by the TI beyond that P16 provides. Okay, so I believe it's like a security testing that we provide. Only if you deem the source is trustworthy, please. Sorry, I didn't. So in terms of security perspective, or from the, if I understood the question well, from the services that we provide and the offensive security into the network function, there is a lot to complement with the defensive side. So into the implementation perspective, and sometimes these are projects that need to be handled within the operator itself. So for instance, it will be the TLS implementation. Of course, if possible, an MTLS, hardening guideline, implementation, hardening guideline, network segmentation, and so on. So all of these contribute to better security of the core network. Because when you look at it, the core 5G core network, it is internal. You know, it is not exposed to the external. So if you do well segmentation and security hardening, you are increasing by far your security posture. I have a question now. Could an attacker spoof a legitimate gNB if an IMF already associates the gNB identity with the interconnection? Yes, it is possible. There are some implementation issues in a way that if we are able to access to this network, so sometimes it is protected by an IPsec channel. So it means that you need to be within this IPsec channel. And you send an NGAP association request by spoofing a legitimate gNB, you can eject this gNB, and therefore the rogue gNB will be working at the place of the legitimate one. How could an attacker spoof a legitimate gNB if the IMF already associate? It's the same thing. Yeah, is by spoofing it, is by taking the relevant parameter. For example, there are some parameters related to gNB IDs. Just by taking them or brute forcing them, you are able to eject real gNBs. At the end, could you address the roaming risk related to the threat model? Also, can you talk through TLS bin metadata that is correlated of users trying to manage their identity? You talk through TLS bin metadata that is correlated for user trying to manage this identity. I don't understand the second part of the question, but if I talk about the first part, that is the roaming perspective, since that everything is coming now, roaming perspective is via the SEPP, right? When we talk about the SEPP, we're going to have different roaming implementation, right? Either it will be managed by the MNO, or a deployment of the SEPP that is managed by, for example, by the third party. So depending on the implementation of the roaming, will be some other risk associated to this. Are we using the prints, or no? We are using some hosted, for example, SEPP that is provided by an IPS network, where they will say, you know what? We keep the prints and the integrity of the different JSON messages that are traveling between the two SEPPs, but with one exception, because we want to add our own header, and therefore this own header, they could constitute a risk. The SEPP also, because we are using the SCTP protocol, it is prone to server-side request forgery in a way that we can forge a message toward the SEPP from a compromised MNO or a malicious MNO and ask the SEPP to forward this message, if it is misconfigured, toward another part of the network. So let's say AMF, it is by design, but also it can go to the operation and the management and so on. So this is some risk that could happen. And the moment or I believe this is something that the industry need to have a look into, and before any implementation to validate them before going live. What is your idea in deploying zero trust on any NF across identity? NF, of course, protecting signaling data, and preemptively any threat modeling done. Apologies for IT-related question, but today I cannot separate IT and telecom from security perspective. It is a really great question in a way that now IT and telco become a little bit the same in a way that we are mixing or using the same technologies. So Kubernetes is not something related to the telco, to Kubernetes, and IPIs is not something related to the telco. They are IP perspective. The only thing that is lacking, to my sense, is the scenarios. You want to do some threat intelligence, or you want to do some kind of detection capabilities. What are your detection capabilities that you're going to implement within the core network, within the IMF? For the IT perspective, we know them. But from the telco perspective, we don't know them. And sometimes we're going to say, like, okay, we are protecting ourselves because we're doing some kind of monitoring, but you cannot monitor something where you do not have proper test cases toward the CM at the end, within the Security Operations Center team at the end, so it can raise an alert that you see something happening. And I think this is things that is lacking today, and we cannot say, okay, this is type of the threat related to the, or what we see today. We may have some threat related today to the 5G core that is implemented, but we are not aware of it because we don't have correspondent detection cases. When it comes to the zero trust, of course, this is increasing the security posture. There are some implementation where I have seen mutual authentication. It means that the network function has a certificate, and with this certificate, it is able to communicate with the another network function. Otherwise, the message, the authentication is not happening, and therefore the communication is not happening. Of course, this is helping a lot. OO2 to define the scope now from the authentication. So we go to the NRF, I want you to communicate with this specific network function. Okay, you are into the scope, you have the right, I give you the token, and then you use this token. OO2 implementation, I don't see it that often. And of course, if it is existing, it will increase the security posture. But there is still another problem. When we put the TLS, MTLS, and everything, there is a question of how can I handle the PKI? Sometimes the certificates that are supported by the network function are not the type of the certificates that are part of the IT organization, and therefore they cannot reuse the same PKI infrastructure. And there are a lot of operators, they don't implement the TLS because of the lack of the PKI infrastructure, and this is another subject and effort that needs to be done so you can achieve this kind of security. So I see some other questions. Pablo, IMF is probably the most connected NF into the SPI, but many of the attacks that you mentioned today could be applied into the 5G core NF. What security controls do you recommend to protect all of them, other than patching? So to be honest with you, my take on this is vulnerabilities, they will always exist. And once again, the AI is helping to discover them. Putting the effort into discovering this kind of vulnerabilities within the different, it is something good, but the effort, to my perspective, need to go to the basics. And again, the basics are network segmentation, attack surface management, patching known vulnerabilities within our libraries and product, and security perimeter. Implementation of TLS, MTLS if possible, or to this is increasing a lot the security posture. Once all these efforts have been done, we can talk about the 0 days. Because in a lot of cases, the attacker, from what we say from the public report, they are not using 0 days. They are using known vulnerabilities, or they are just leveraging default passwords, problem of network segmentation, to go deeper within the network. How realistic is the risk of a compromised NF in a real 5G network? So it is plausible for the specific reason. So we have, this is something I touch into, it's like we have numbered or known big vendors for telco. right? From threat landscape, it makes more sense for a state to compromise a vendor to put some kind of code in it, because if this effort is done and they manage to have some supply chain risk there, this risk will be implemented within many MNOs and also within many MNOs into one country or different country. And you see, today also we are talking into a lot of, if you see the NCAC reports, for example, the NCAC report, you're gonna see the term of high-risk vendors. So why we are talking about high-risk vendors? So for multiple use cases, either related to the sovereignty, in case we have some geopolitical tension, or also from a case that one country will decide to put some malicious code implant within the solution that they are provided. So it means that today, from the threat landscape, it is taken seriously. Thank you, presenting. Many of the IMF vulnerabilities presented appear to be weaknesses in the vendor software design or implementation rather than issues introduced by the operator deployment. Okay. From an operator perspective, what unique value does IMF penetration testing provide beyond the vendor-owned security deployment lifecycle, product security testing, and vulnerability management process? How do you distinguish findings that are actionable by the operator versus those that are require remediation by the equipment vendor? So the reality, what will be interesting for an operator, it will be more related to the infrastructure itself, because the vendor, they are not managing the infrastructure itself, right? So think about the risk that could be coming from managed service provider or managed service security, managed security service provider, right? You can have, for example, using Ericsson, Nokia, Huawei, or whatever. They can manage your own solution. They will have some kind of VPN access. How is this access? It is handled to your infrastructure. It is well scoped and segmented, or one compromise of an MNO could lead to the compromise of the whole operation and management network. So the operator, to my perspective, they need to look at the asset that they are managing. So outside of the bug, they are coming from the vendor. Once again, hardening guideline, because sometimes the username and password that they are handled or deployed by the operator are not the vendor. Sometimes the vendor is the one putting, for example, username and password, and they're using either default one, they are known into the documentation. And here, there is a little bit of ownership also from the operator perspective, because the operator perspective, they need to validate the post-deployment. And therefore, you're going to get all the information from the vendor related to the user that they have been implemented and so on. So make sure that the user that they are set there, that they are secure. It should be part of the process, and also the network segmentation that you're going to handle within your infrastructure. How to set up a fully controllable malicious UE toward the commercial gNB and IMF setup. So controllable malicious UE. So I may understand this, I may not understand the inner, I would say, or the intent of your question. Because like malicious UE could be an SDR that you can, or a modem that you can put SIM within it, and you start sending or fuzzing either the RAN part, RRC part, or fuzzing the NAS part and targeting the IMF, or going directly via the IP level and try to reach some services because it lies from network segmentation issues. Aside from that, there are some mistakes that they could happen, and this is related to the forwarding network function that would be, for example, the UPF. It means that from the UE perspective, it is able to access an IMF or access to services from the IMF could be an NGAP. So this have been demonstrated into a paper, a research paper, and they showcase that from a UE perspective, they are able via the UPF to forward within the GTPU message, forward NGAP messages, and therefore registered remotely some gNBs, and therefore putting a rogue validated gNB into the network. So for me, there are still some research paper in a lot of implementation that I have seen myself, problem of forwarding within the UPF in a way that will allow open bar you want to request an NGAP, etc. This is not usually happening. It may happen into the lab, and we find it into the lab, but when we check into the production, it is not the case. Oh, in the sense of NAS and NGAP fuzzing, sorry. So in the sense of the fuzzing NAS and NGAP, you can do it via not SDR. It means that you have the module and you try to inject NAS messages via the radio. And the reason for that is like, it is possible to build it. But if you build it, you're going to have limitation from the radio stack itself in a way that you are not able to send a lot of packets at the same time. And therefore, your fuzzing capability will be slow. What could be done is like you take the IMF as a network function into the lab, and you are exposing the NGAP SCTP protocol, and you build a UE and the gNB. There are a lot of solutions today. So you can use, for example, the Uran SIEM. You can build a virtualized gNB, and then you can build a malicious UE with some kind of a software. You will just control the NAS messages they are sent. And therefore, you can achieve the fuzzing on the NAS or also on the NGAP if you build this stack of sending malicious messages from the virtualized gNB. So all in all, the fuzzing, it is happening from the IP perspective rather from the radio perspective. Pierre, pretty impressed by the speed of the reading. I take this as a compliment. Thank you very much. Finally, thank you for your presentation. What is Amina?
Thank you, Mehdi, for all these answers. We had a lot of questions this session, and thank you for tackling them all. We are just 11 minutes past the time, so with that, I want to thank everyone for being here, for your presence, for your questions and interactivity. And a big thank you again to Mehdi, who had an amazing session, gave us a lot of insights. Be sure to follow us at all our pages, contact us if you have any other questions. We will be sending the recording just shortly after this call ends. So make sure to check it out if you missed any parts of the session. So with that, we'll be closing. Thank you, everyone, and have a great day, great night, great evening. Goodbye.
Thank you very much. Bye-bye.